Okay. Hey everyone, thanks for coming to this session. I'm Matt Fontana. I'm head of ecosystem at this project called Streamr, which is a decentralized pub sub. I actually started my career as a front-end developer, somehow ended down this crazy rabbit hole that is crypto and Web3, and here I am, and really excited to share the story of Streamr and how we've gone about building this decentralized pub sub. So this is the format of the talk. I'll explain what it is, what exactly is meant by a decentralized pub sub, why build it in the first place. I think that's sometimes often overlooked. How it works, of course, and the native use cases of the network. Okay, but before we dive into the decentralized pub sub, let's first recap on what we mean by pub sub. So pub sub is a networking architecture. The key characteristic is that the publishers are decoupled from the subscribers. And that means that as a publisher, I don't need to worry about connecting to all the consumers of that data feed. I can push it to one centralized piece, a server, data center, and that data center takes care of the scaling and the connections, and it's quite an elegant solution, especially for IoT. And this is another kind of visual representation of that same system. Data publishers on the left. Typically, it's a business or an application that has some kind of SLA agreement with a cloud provider, and some cash is exchanged for services, and this works very well today. So, what exactly is Streamr? Well, it's the decentralized version of that. And what are we decentralizing? It is the middle piece of the pub sub architecture. So what we're replacing the data center with a people's network of nodes. So instead of the data flowing through one centralized point, it's actually flowing through a decentralized topology made up by the users that are interested in the stream, as well as others that have some sort of vested interest in propagating the data, which I'll get to a little later. So the key takeaway here at the moment is that instead of credit cards and SLAs, we have smart contracts and the native token of the network, which is the data token. So at this point, I'd like to point out, perhaps if you're kind of coming into the space thinking everything is a blockchain, this is not the case for Streamr. Streamr is a crypto economic system. It uses a blockchain, but it doesn't. The data doesn't flow through a blockchain. I think that would be quite a silly idea if we built this pub sub system where the data flows through blockchains. So we use classical networking protocols. WebRTC is the main one. So the data flows through the data channels of WebRTC, and this is how the peer connections are formed. Blockchains are used for access control. There is a token currency, which I'll get to a little later, and this is for the incentive layer. There are smart contracts. Again, I'll touch on this in the technical section. There is DAO governance. So this is quite interesting. So token holders are analogous to shareholders, for example. And the token holders can propose improvements to the protocol, change parameters, influence the monetary policy of the system, anything they want. And the DAO should act in the best interest of the token holders and the ecosystem. And of course, there is the community, which has a lot of overlap with the token holders, but of course, it can be anyone that wants to see this technology be built. So there is quite a diverse set of stakeholders in this system. Okay, so that's quite abstract. admittedly. Let's get into an example of what this technology is about. So this is the Streamr.network website, and it's just like any other website where you, when your browser or your phone loads the page, there is some JavaScript, comes from a server, some image assets, they come from the server. But if you scroll down the fold a little bit, you'll arrive at this data feed. And what's interesting about this data feed is that data is not coming from the server. It's actually coming from other visitors that are on the website at the same time as you. So this is the Network Explorer, and in the top left I have inputted the stream ID of that data feed on the website, and what it returns is all the nodes that are currently active on that stream. So these are the visitors of the Streamr.network website, and they are forming peer-to-peer connections with each other, and they are propagating the data to each other. And so as a visitor, I'm getting that data from other visitors of the page. And perhaps another kind of point to clarify here is that the Streamr network is not a monolith, it's a constellation of these different stream topologies. So this one is for the Streamr network website, and there can be infinite number of streams all on the Streamr network. And there is some coordination that happens network-wide, but there's a lot of things that are stream specific as well. Okay, so maybe a quick pause here and ask why. So if it ain't broken, why fix it? And real-time data flows through the internet today, and why are we even bothering? So there's a few reasons. I'll put to that there's no single points of failure in a decentralized system. So these big cloud providers, when they provide these services, they are fantastic. They barely ever break, but when they do, it can be quite spectacular. So I think we've all seen when a third of the internet goes down, when Cloudflare has issues, and these sorts of political risks as well, having one company own a lot of the flow of data going through one kind of company, even if the data centers are distributed around the world. It's permissionless and censorship resistant. So again, speaking to the ideological benefits of decentralization here, the Streamr team can't stop anyone from running nodes and pushing data, so it's an unstoppable data stream. There's smart contract composability. I'll get into this a little later in the technical section. It's free to use under ideal conditions. So similar to BitTorrent, if you've ever used it to seed and leech files, you'd notice that it just works. You don't have to put in any money. But for production quality service, there is an incentive layer that you can optionally add, which I'll also get to later on. And it's energy efficient as well. And with a bit of a disclaimer here that we don't yet have the hard data on this yet, but it's quite believable that by using the latent bandwidth of already on devices, we can compete on some use cases against always on power hungry data centers. So I think that there will be a story to tell, but we don't yet have the hard data on this yet. And Web3 is about open protocols, and it's not about closed platforms. So we want everybody to kind of have ownership of the infrastructure and of their own data, of course. And that's cliche, but that's what Web3 is all about. And this tweet always gets me. It's, you know, we've kind of moved towards this Web 2 situation where we create all the content and the companies are taking all the money, whereas in Web 3 we still create the content, but we start to make we start to have ownership of the content, and we start to have ownership, if we choose, of the infrastructure that's powering those content platforms. Okay, so now into the technical section. How does the data flow? So let's say, for example's sake, I have a live data feed coming from my phone, or all the sensors on my phone. I want to get them out to everybody at the conference. How can I do this? There's probably 3 ways that I can think of. I can connect to everybody at once and kind of make connections to everyone. This would make my phone very hot, and it would not work that well, I would posit. The second way is the rational way, where this phone connects to a big server, and that server connects to everybody else, and the data flows quite well. This is the Web 2 way. With the Streamr protocol, what would happen is that this phone would connect to 4 people at random in the conference. Then those 4 people would share the data with 4 other people at random, and so on until all of the subscribers that are interested in that data receive that data stream. And this happens very fast, so we can scale to tens of thousands of subscribers very easily, and the latency stays under 1/3 of a second. So we are a real-time data infrastructure project. So this largely is saying that the protocol works on this principle of shared responsibility, where the nodes that are intrinsically interested in the data streams, in the data of the data streams, they have a little bit of work to do. And so this is how the protocol scales. Yeah. So under ideal conditions, this works just fine. Everybody's happy to digest the data, and they share it to their peers. Everybody's staying online. But in the real world, we have problems, and in decentralized systems, these open systems are always being attacked, especially if there is value. If there's a game to extract value, and people can be anonymous, these systems get attacked all the time. So the problems that are specific to data propagation are the peers can churn. They can come and go as they please, and that can disrupt the data flows. We could have free riders, so somebody could come in and just view the data but not want to share it around. And then there can be downright malicious nodes that actually make eclipse attacks on publisher nodes and kind of lock them out of the network even. So there's these are really tricky problems, and it's probably why a protocol like this hasn't come up yet. So what is our solve? It's what we call bounty contracts, and this is the incentive layer of the Streamr network. And a sponsor comes in and creates this bounty smart contract on Ethereum or Polygon or some sort of blockchain, doesn't really matter. And they fund the bounty contract with some data tokens, and this acts as like the security budget for the stream. And what this does is it incentivizes broker nodes to come in and join the stream topology as these paid actors, and it incentivizes them to be honest and good actors in the system. So in our analogy where we wanted to get my phone's data stream to everybody in the conference, and maybe half the people in the conference are free riders, let's say, then I could put a bounty contract out, and this would incentivize, let's say, people from the street to come in, pay them money to help propagate the data around and add like this backbone to the stream topology. And so it's not a free lunch. There is risks involved in being a broker node and participating in these bounties. So if you accept this kind of promise to be a good and honest node, and you churn or you are malicious, then your stake can be slashed. And by stake, I mean for these paid actors to come in, they would need to kind of put a bond down and say that I'm going to be a good guy, and then they can start to earn rewards. So this is the Web3 version of an SLA, essentially. It's a bit more, quite different, but serves that same purpose. And then lastly, on the technical section, there is the access control. So this is the on-chain stream registry. So this is another touch point we have in the blockchain. It's a network source of truth. So the nodes are looking at the blockchain and seeing who can publish and subscribe to these streams. And it's quite an interesting kind of touch point as well, because with this on-chain stream registry, we can now create or imagine imagine exotic access control policies. So for example, instead of me just creating a stream and choosing who to publish and subscribe to in that stream, I can say that you need to own an NFT to join the stream and publish or subscribe, or perhaps you need X amount of token. So we can have quite interesting token gating features. Okay, let's move on to the use cases. So there's three main use cases for such a piece of infrastructure. It is generalized messaging, open data sharing, and data monetization. Generalized messaging, this can be humans to humans, I can't think, well, humans to machines, let's say, machines to machines. What we're also seeing as well is quite interesting communication of nodes in other decentralized networks. So especially validator networks that need to talk in some way to each other, to express their local real-time state to each other. The Streamr network is a great technology choice, because that data is not flowing on the blockchain. It's not really restricted. It gives this opportunity for free, fast, real-time communications. An example of some human-to-human communications is a chat app. So this is pub/sub kind of with a UI, you can say. So chat rooms, kind of like a WhatsApp chat room, a group of participants, they can all publish and subscribe onto that stream. And when they send messages, they're cryptographically signing them with their own private key. So you have strong assurances that what they're typing, what they're sending is absolutely coming from them. And then you can imagine social experiences where you can have this token gating chat rooms, so you can chat with other people that own the same NFT as you, for example. And there are no servers in this system, so this is all peer-to-peer with a front end. There is another cool project called Redstone. They are using the Streamr network as the first mile of data transport in their Oracle system. And once their nodes, the cache nodes, they kind of listen on streams, and then they store the data that is streaming. So maybe one point here, if you're wondering, Streamr network is an ephemeral network. We do offer storage, but it's done in a bit of a centralized way at the moment. So we really depend on other ecosystem partners to either store the data, or we can do that, of course, but it's slightly centralized. Then moving on to open data sharing. So this is great for governments and big enterprise that just want to make available as much data as they can. I think this is quite a strong public good, that they don't that the open data can flow through open data protocols. And then there's data monetization. So this is always kind of a hot topic. Monetizing your data can bring up a lot of emotion, of course, and so I want to make clear that we're doing this in a very ethical way, with the user in full control and ownership of their data. And this was the vision from the beginning. And the network can host these native data DAOs, or data unions as we call them, that allow anybody in the world to contribute their data in a shared streaming data asset that can be monetized for fair reward. So this is the architecture of a data union. There is a data mining application that asks for your rich consent, and you get to decide if you want to monetize a certain subset of your data. That data flows through the Streamr network, composes with the marketplace and data union smart contracts, and at the end of the day, it arrives at a user interface for the data buyer. Data buyer puts in tokens to buy access to the data stream, and the access control policy then enables them as a subscriber on that stream. And when they do put the tokens in, those tokens get fairly distributed among all the data producers that helped create this data set. So we don't take any cuts here. The data flows through these decentralized networks, and it's the data providers that see the upside. So one example of this, one of my favorite projects, Demo. This is a roaming car data mining network. So what they have is a Raspberry Pi style device that plugs into your car. You drive it around and you have this drive to earn experience where the data starts flowing through the Streamr network, and you start to earn tokens for this. And there are open data angles as well as monetization angles as well. So you can help the city find the potholes and get rewarded for this, or you can perhaps sell your data to the manufacturer so that they can understand the fleet better. And this is kind of happening already behind our backs. We're not getting any rewards for this, so this is obviously all opt-in if you choose. But I think it's a very strong pattern that gives fair reward back to the data owner, which should be you. If you own the car, you should own the data exhaust that comes from the car. And then there's Swash. So I think they're around 50,000 strong now. It's a browser extension that does the same thing as Demo, but with your browsing habits online. So this is for MarTech sort of use cases. Okay, so this is our final milestone coming up. So I'll just say that we've been going at this since 2017, 4 or 5 years of research and development. We decentralized the network in February this year, so it's all quite fresh, and we haven't reached the 1.0 yet. So the 1.0 is the bounty contract milestone that enables the incentivization layer of the network, and that's coming early next year, and then we'll be kind of feature complete. Yeah, okay. There's like I could probably go on for hours, so I'm sure there are gaps. Happy to answer any questions, and thank you for your attention.